Scholars, let's talk about exponential functions. Exponential functions are functions to the form f of x equals ab to the x. A cannot be zero, and it's any real numbers except zero, obviously. B is bigger than zero, always is positive, and it cannot be one. That's the definition of exponential function. They're very unique, very unique functions. And what is clear, this one, exponential function makes that exponential if the percentage change is always the same. And we'll talk about that in a few. The domain, obviously, is defined for every real number. So domain is all real numbers from negative infinity to infinity. The range, it never touches zero. It will be from 0 to infinity, or all positive numbers, from 0 to infinity. Okay? So that's the domain and range. It experiences a horizontal asymptote here. It always growing here or decreases here. If b is bigger than 1, if this is modeled, this is called an exponent. This is what we call an exponential growth model. And if b is between 0 and 1, it's an exponential decay. Let's talk about a in this case. A is called the initial value, but that's your seed or initial value. Is, of course, your y-intercept. And b is called the base. So the base is always positive and it cannot be 1. If the base is between 0 and 1, it represents an exponential decay. If b is bigger than 1, it represents an exponential growth. So I told you that what is so unique about exponential models are that the percentage change is always the same. So let me just erase this and let's talk about that a little bit. We always contrast exponential function with the linear function. Weird, right? But anyway, so linear function is of the form linear function, of course, mx plus b. B is the initial value, and m is your rate of change, is the slope. Is nominal. And this is, of course, b, the initial value, or the y-intercept. Exponential, f of x equals a b to the x. Initial value, percentage change. So, for example, if I go to the bank, let's say that I win $500 from that, how do you call it, the scratch off from Publix at the Lotto, and I win $500, and I decide to deposit that in a bank account and forget about it. So I go to Bank of America, knock, knock, knock. Bank of America give me an offer for my money. So, okay, Bank of America, I'm going to offer, I don't know, you deposit my $500 and I'm going to give you let's say $5. That's kind of cheap. Let's say I'm going to give you $5 annually as interest. So my model would be f of x. Of course, I deposit my $500 and I'm going to get $5 every year. So it will be 5x plus 500. Every year, Bank of America is going to give me $5. 500, 505, 510, etc., etc. So I just add $5 as I move 1 unit up, right? This is 5/1. That's your slope. Of course, if it's exponential, Citibank or whatever, Wells Fargo offers me the following model. So I'm going to give you, I don't know, 2% increase every year on a percentage base, nominal base. So the model will be, of course, f of x. My a will be my $500, parentheses, 1 point is one more, 2% in decimal will be 0.02 to the x. So every year, uh, uh, Wells Fargo will give me 2% on interest versus Bank of America will give me $5 on interest. So that's the difference. This one grows as a percentage base. This one grows as a nominal base. So anyway, that's the difference between one or the other. Let's talk about potential function more details. Let's say that, I don't know, I have the following model. Of course, it's exponential. I know it's a b to the x. A is my initial value, and this one is the base is 1.13. Since the base is bigger than 1, of course, this is an exponential growth. So my initial value will be 10, let's say $10, whatever. And then the percentage growth in this case, because it's growing, will be 13%. If I have, of course, f of x equals 50 parentheses 1 point, I don't know, 57 to the x, perhaps you guessed it, that it will be $50 the initial value, and I will be adding 57%. Okay? If I have f of x equals 1.89 to the x, let me do something different. Oh, sorry. Just use one that is only if I have 1.089 to the x. Notice my initial value is 1. There is an invisible, there's an invisible 1 here. Okay, so if I do this, that will be 1. So my initial value will be 1. And this one is growing at what percent? It will be 0.089, which will be 8.9%. Okay. And of course, if I have x equals 2 to the x, once again, my initial value will be 1, which is invisible. And this one is going at what rate? At the rate of 100%. And probably you already figure out that it will be, the percentage is everything above 1. So the base minus 1, 0.13, so 13%. The base minus 1, 57%. The base minus 1, 8.9%. The base 2 minus 1 is 1, so it's 100%. If something is growing threefold, 3 times, this is duplicate of 3 times, so that would be f of x equals, if I want to grow 3 times, that would be 4 to the x, that would be 300%. This one will be growing at 300%. Okay, so for example, if I ask you to erase this, let's take, we get a great bonus at work of a fantastic job, and the bonus is, I don't know, $2,500. And we choose to deposit that $2,500 at the rate of 9.25%. Yeah, we wish annually. Okay? Of course, this has to be in decimal. We know that 9.25% is the same thing as 9.25%. If I divide by 100, that would be 0.0925. 925. Okay, so what would be my model? It's exponential because it's growing on a percentage base. So it has to be a model of the form f of x equals AB to the x. So my model will be f of x equals AB to the x. My initial value is 2,500. Now, that's the seed money. And its growing will be 1 plus this guy. So 1.0925 to the x. Now, let's say this will be the balance of account after X years. Okay. If I want to say, well, how much money I'm going to have after 7 years, I'm just making this up. So we just simply have to evaluate the function when X equals 7. So f of 7 will be 2,500, 1 plus 0.925 to the 7. So f of 7 will be that to the 7. And at this point, we leave the calculator to the work, and let's see what we have. Just 1 second. So let's see what I have. Let me erase this. So what do we have? 2,500. That's my seed money. Parentheses 1.0925 raised to the how many years? 7 years. So after 7 years, our lovely account will have 4,643.98%. 46, 43, 98. It's about, okay? So would be the balance of the account after 7 years. If we deposit $2,500 at 9% every year. Okay, so we talk about exponential growth. What about exponential decay? Because how do we recognize exponential decay? The base is always between 0 and 1. The base cannot be 1, the base cannot be negative. So I can have the following example. If I have f of x equals 10 parentheses 0.85 to the x, I know this is my initial value. So therefore, first of all, I know it's an exponential because it's ab to the x. So this is a, this is b. The base 0.85 is a decimal fraction between 0 and 1. So of course, it's an exponential decay. So we start with $10 or $10 or 10 something, and we are decaying at what percent? At 15% decay. If I have f of x equals 100 parentheses 0.59 to the x, so the base here is 0.59, so this one decays at 41% decay. Okay. So hopefully you get the, how do we find the base or the percentage? If you want a 45% decay, the base has to be 0.59. 1 minus the base will give me the percent. 1 minus the base, 1 minus 85 is 15. 1 minus 59 is 49. As I always try to summarize, the base is never 1. However, if my base is 1.25, this one represents what? 25% growth. If my base is 0.75, 0.25, 0.25, this one represents a 25% decay. If the base is 0.75, 25% decay. If the base is 1.25, that represents a 25% growth. Okay? If I want to have a model that shows a 25% decay, I will have to do 1 minus 0.25 is 0.75 the base. If I want a 25% growth, 1 plus the percent will give me the base. So you can play with the formulas, depends on what you're looking for, either the percent or the base. And so just a very simple example. Let's say that we own a company, and part of this company, we acquire a truck or a piece of equipment worth $40,000. And of course, in the business, this asset, we want to depreciate it. Depreciation. And we look at the documents, and I don't know, GAAP, the generally accepted accounting principles tells me that we can depreciate this asset, this piece of computer or server, whatever, at 17% depreciation. So if it's 17% depreciation, 1 minus 17, I mean 100 minus 17 will be what? 83. So we already know what is the base. So what is my model here? F of x equals $40,000 initial value, and this one is decaying at a rate of 17%. 1 minus 17.83 to the x. 83 plus 17, that's okay. So if you want to find what is the value of the asset after in book value, obviously, after 4 years, the value will be 40,000 parentheses 0.83 raised to the 4. So 4, we let the calculator do the work. So let's see what we have. To put this here, 0.83 raised to the 4. After 4 years, what's the value of our computer, of our server? 18,983.33. Yeah. Okay. So that's your exponential function. Just a quick introduction of what is an exponential function. Thank you.